All right, couple things. So you all got your test back. You also got your free response question back. So the test, first thing, test corrections are due on Thursday, whether you are in school or not. I find on days that things are due, a number of you happen to have doctor's appointments that afternoon to start right at the beginning of seventh period. If you are here, like even if you're not here, snapshot and upload corrections by Thursday. I need those corrections by Thursday, whether you have an appointment or not. Yes, ma'am.
So use a snapshot upload to turn them in online or in person?
So I want them on paper, but if you are physically not here to turn them in, that is not an excuse to turn them in on Friday. Rasheen, you did not get yours back because I didn't see you. Do you have them? Okay, so the deal with corrections. First of all, do not write anything new on the test paper that you just got back. So those of you who are writing on it now, stop. Because I need to see what you did first, what was wrong, and then on separate paper, clearly labeled with all work shown. Number one, this was the question. Then, like, you don't need to write all the words out. You don't need to write the full sentence of things. But show the math that you were given. And, oh, I needed to do the derivative. You don't need to say, I need to do the derivative. But f prime equals. And then show the work from there. Clear and logical and labeled. Don't just have arithmetic bark on the paper. The arithmetic needs a name. Is it f prime at 3? Is it g prime at x? What is it? So, anything that you lost credit for, even just half a point, this one isn't relevant to this test, but if the only thing you lost credit for was units, you didn't put units on the thing, you need to do the whole problem start to finish and then say, that was 5 feet per second. You need to do all the work over again. You don't get to pick up where you dropped or made a mistake. Ayala, you were going to ask?
No, my English isn't
Okay,
like this.
so the deal for getting the points back, so your notation needs to be correct, everything needs to be beautiful, and it's due on Thursday, just a second. So if you lost, as it says at the bottom, ideal is you will get half the points back that you lost if all of the corrections are complete and correct and you follow directions, notations right, and it's gorgeous. So a 30 out of 40, that's 75%, that can become 30 out of 40, 35 out of 40, which is much closer to an A. So if you do the corrections, you have a lot to gain. Yes. Yes.
I only got 100.
No one got 100. Question.
Do we have to use like the I or the C or the R?
Okay, so the I and the C and the K, that's my way of seeing if you guys can assess your mistakes. So I like to see that, and I, like, in going through the mistakes that were on the test, are they careless mistakes? Because that means slow down, take your time, read the question. My statements on how to do all these things, step 1 is read the question. Step 2, no really, read the question. Because some of you answered something else. You showed correct math, but you answered not what I asked. And a K problem is like, oh, I forgot the derivative of sine, or I forgot the derivative pattern for arctangent, or I just forgot what arctangent was in general, which a number of you did. That's just a little bit more time studying, remembering some pre-cal, remembering some prerequisites. If there's a lot of I questions on there, like, I've never heard of derivative, no idea what this concept is, that kind of, if there's a lot of those, that means you're in the wrong class. Like that you don't remember enough of what we needed to do, that this is probably a bad fit. So if you forget to do those, I don't mark off anything for that, but it's meant as a diagnosis tool to figure out the communication back and forth. But also, what I find when you guys do these corrections and you label everything, oh, it's careless mistake, careless mistake, careless mistake, and your answers are still wrong. That means it's not careless. It means that you don't understand how fractions work, or you don't understand exponents, and it's where we fix years of incorrect math that you got from 7th grade on, and can start to help you not make those same mistakes in the future. And it sucks for everybody. I hate grading these. You guys hate doing them. It's one big hate fest. But it's all like good for you and stuff, sort of like doing push-ups. Anyway. Questions about the instructions? I need the test and the separate paper with all the corrections neatly written out, turned in on Thursday. And whether you're here or not, Eric, I will have pictures of them in my inbox if you're not here in person, right?
Yes, you will.
Okay, checking. Cool. Yeah?
You go over like one question.
What one question?
7A or just 7 on the white one.
7 on the white one.
I had no idea what it's all. I had no idea.
So that's given the derivative and a graph.
Find the slope, you integrate it, and then plus the 7. Yeah.
This one?
The slope is negative.
And this is f prime of that?
Yeah.
None of the choices. Okay.
Oh my god, we gotta add the y. Wait.
What was, they told you this too?
5.
Okay, so guys, integration, the integral from 0 to 1 of f prime of x. I always ask Carson for this. He's like, oh, the integration, hey, Evan, is what's the area under the curve? So the area of this triangle is 1/2 height times base, or base times height. So the area under the curve is 3. What is the meaning of that? What is the meaning?
The integral is 3.
Right, the integral is 3, but what does integral mean?
Oh, the area under the curve between the x-axis and the
Meaning,
rate of change.
meaning.
The rate.
If this was velocity,
Accumulated
integral-
change.
accumulated change.
Right.
So it is how much my position, if this was velocity, this is how much my position changed. The question said, where are you at 1? Your position changed from position 0 this much. So your position started at 5 and you accumulated a change of 3 units of whatever it was. So your answer
That's gotta be.
is 8. It is not the hardest question. It asks you, do you understand what integration means? Yes, it's area under the curve. Yes, it's the integral. Meaning, what does it mean? This is how much stuff changed. Where did you start? At f of 0? Was not 0 there. It was starting off at 5. Isaiah?
Can you like show us how to do the question that the least amount of people got right? Oh yeah, what about?
We're going over number 2 on the white.
Okay, guys, we actually have material to do today, so it is on you guys to figure out these questions. I am going to be out tomorrow and Wednesday, but I have asked the Calc kids from last year to come back at lunch tomorrow and Wednesday to help you guys go through quiz or test corrections. So yeah, this one is a learning experience for you guys to go back and figure out what's going on. Okay, sorry I'm not gonna be here, but I'm not. So,
They come for lunch. Yeah.
I can't stop the lessons, the material that we're going through to reteach and go over and do all the corrections for you. That one was free, and you got one, okay? All right, today we are doing this thing called slope fields, which, Eric, involves differential equations. You were just asking. Okay. a differential equation gives the slope of what's going on, what's the rate of change at any moment. And let's see. So I have a packet for you for some things, but this isn't in there. There's too many words under here, but we're going to do this thing called a slope field, and I think it's probably better if I give you an example. Isaiah, what's the integral of 4x?
So it's like,
Raise the power, divide by the new power. We're missing something. Plus c. So a slope field is all of the integration things that could have been. So let's see.
Is it kind of like how you we factor to find out that zero is like so you could have different values? Possibly.
Kind of. Okay. So see this? It kind of looks like fur. If I integrate 2x, so I had Isaiah integrate 4x. Okay, so this is 2x. Here's one possible solution. Here's another and another and another. What does it look like is going on with these equations? Are they similar in any way? Josh, what's the only difference?
The intercept.
The intercept, so a vertical shift. Eric?
Yeah, so different.
Are they? So right here, all of them at their vertex, and all of them have the vertex on the y-axis. The slopes are 0 here. Right here, the slope seems to be about the same for each of these. It's a small positive number.
Okay.
Everywhere up there. So across the x's, I realize it looks steeper here because you're comparing not at the same x value. But the slope field is the picture of all possible solutions over time. Like if we wanted to look at a weird equation. No offense, cosine, but I'm calling you weird. If the derivative is cosine, whose integral, whose derivative is cosine? Sine or positive sign or negative sign? Sine. So look at this slope field. Does it look like a bunch of wiggles that hit with a 0 or the midline at, do you see sine curves in here?
Yes.
Do you now with them clicked?
And they're just going like up and down.
They're squiggly wiggly like trig curves. Yeah? Yes. Okay. So, all right. So that's what a slope field is, and we are going to create one. So the packet that you just got, or got the cracked on, did everyone get one of these or no?
I didn't realize I had all of them picked on them.
Sam had all of them, so this whole row didn't get anything.
You guys don't need to do it anyway, it's fine. I'll do it.
Okay, he's volunteering to do all work. John, you got one? Yep. Okay.
So we must.
So let's
No,
figure
you're
out how
not.
to generate these. This first problem is telling us dy dx equals 2x. And here we're wanting to find the slope at a whole bunch of different points. And it gives the x and y value of the coordinates. Asher, does the y value get used in our slope? In calculating slope? So that doesn't matter at all. Okay, so Ananya, when I plug in -2, what slope am I gonna get? -4. So guys, go through and calculate what these values are. So the x value times 2 is our slope. Okay. Then we gotta graph this. And we're not gonna graph a line, a big long line. It's just like that example, the graphs that I just showed. They're tiny little paddles. So going to the coordinate -2, 0, we're gonna put a little bit of a paddle so that it has a slope of -4. And -4 is, for real, steeper than this. But I'm gonna make this -4, and wherever else I want to draw a -4, make it the same steepness. And I'm gonna graph the 3 that they asked me for. Carson, making sense? Yeah? No? That was the circular nod, which is... No? Okay, let's see if this works then. Let's look at these coordinates. When x is 0, the slope is 0. When x is 0, so make a 0 slope. Those are easy, yeah? And a short little segment. Looking at these guys, when x is -1, the slope is -2. And, all right, I made -4 this steep, 0 is that way. I need to make it look like a negative slope, less slanty than the way I made -4. Logan, no?
No, I get it.
Okay. These are tedious. I apologize. So Liv, how am I gonna graph these guys when x is 1 and the slope is 2?
You're gonna graph it kind of like at,
So the same slanty
yeah,
as the
the same
-2,
slanty,
but the
just-
other way.
like reflected across the y-axis.
Yep. Slanty, that's the official math word for it, Iris. Get over it. And how am I gonna do these, Iris?
The same as the -2, but the other.
So more slanted than +2, preferably the symmetric amount is the -4. There, we just graphed a slope field.
What's the point?
What's the point? Okay, so this gives us an idea of what might be going on. Any of you have parents that work at Naval Surface Warfare Center, Carter Rock? No.
Set off the car.
It's cool. They have an explosion tank.
Wait, what
It's so cool. They wouldn't let me go. My students were like, go figure, they wouldn't let you in the explosion tank. You know what shape the explosion tank is? They throw things in there and
A circle.
it's not a circle. Reverb would kill it. It's not a circle, not an oval.
Triangle.
Square would also reverb on top of itself.
Is it like
It is pentagonal.
Why?
So that the reverberations of the explosions don't like come on top of itself. And they have an anechoic wind tunnel. I don't know how you can do that, but it's cool.
What is it?
Wait.
Doesn't make noise. Like
How is
the
that possible?
I don't know.
Wait, is
Like-
it like inside it does it make noise or like outside?
Well, wind tunnels to run make a crap ton of noise. So I don't understand what an anechoic is, but it is something that
The United States
What's the
Navy has access.
Why do you want to
I don't know, but
We all love a little.
They didn't let me see that one either. They didn't let me see that one either, but I know about it because I have a sibling that had to run tests in it. I was like, so what are we working on this time that is a required thing?
I think we should have a class field trip.
It was cool, you know?
Yes.
You're not even in my class. However, I've done weird things like take your child to work day at a place where I did not work with a group of kids that were not mine. How stupid is that?
How did you get through that? How did you make that one happen?
NIH had a cool lab and I was running the robotics group. I'm like, let's go! These aren't my kids. They're like, yeah. I didn't work there. I'm like, cool, it was neat. Really, it was so cool. They have really great toys. Anyway, back to this. This is supposed to be tomorrow, and then I won't be here. We're going to show you some of this. So, these are big questions on the free response. We want to separate these variables. So let's. I hope you have some space on that worksheet. I'm going to move x stuff with x, y stuff with y. There's no y's there, so really this is just dy equals 2x times dx. We have just separated things.
Oh.
And because you're going to yell at me in a second, we're gonna write something over here. Carmen, what is the derivative of y equals 5x? And what do I put on this side? dy dx. Okay. All right. Morgan, what is the integral of 2x dx?
2x. Not 2. Wait, no. It's it'd just be x squared.
Raise the power, divide by the new power, and then plus c. Okay. What is this side integrated? What number, Jackson, what number is on the dy? It's not written.
What?
1. So if I said integrate just dx, what would the integral of dx be?
X?
X. So what is the integral of dy?
Y?
Okay. So my equation is y equals x squared plus c. So visually, hang on, Eric, what this slope field is that you guys just created is, if we did all of these, it's all of the possible answers with every plus c taken into account. So here we integrated, we got x squared plus c, and the red stuff kind of looked like if you dropped a pebble in the water, it left all these little parabola imprints, right? Maybe. Yeah. Okay, not a lot of yay on that. Okay, so that's separate the variables and integrate. Francis, this last piece here said, you know what? Like, sketch the one solution. I want to actually get the equation. What equation makes y of 0 negative 1? What do I have to do to figure that out? I have all of the answers, the general solution, every equation that has a slope of 2x is this. I don't want every answer. I want the one answer that goes through the coordinate 0, negative 1. No idea? Sam, what do you think?
Is it the parabola? It's gonna start at 0, negative 1.
Yeah. So put in 0 for x, negative 1 for y, and solve for that c value. Kian, what is the c value going to be that makes this coordinate work? C equals negative 1, so the particular or specific solution that has the slope of 2x that goes through this coordinate is going to be this one solution. Like that. So a slope field is kind of ripples on the water of all plus c solutions to a particular slope. All right, can you guys try creating the slope field for the second page? Yeah.
I have a couple questions for you, if that's okay. So I actually encountered this is exactly what I did in history, and I didn't really like it. It was the same thing. Yeah,
What?
yeah, so I don't understand. How are we doing?
Mr. Richard.
Basically. I don't understand
What? He is, yeah.
I don't understand.
We've driven him out.
That's not for very early 2 days.
Yeah, why is there?
Sounds like
there's
someone's
such a
better like next to
first and foremost?
It's the one left that I have.
Assuming they still have it.
This is the same thing.
Yeah, but it probably they'll probably this was something else. Mr.
Well,
Gilmore's
why
gonna
is
be
it
like,
different Tuesday?
idea. I am a human person, so.
The human sciences. Computer.
Do you only get a C when there's a 2x?
No, you only get a C when it's indefinite. When it's a definite integration, the C's cancel out.
All right, guys, hold on. So, forgot about this. It's a question every time. There might have been a constant on the right, so when we integrated, we added a plus C. But maybe there was a constant on the left. I didn't add plus C there. And why? Well, I have some unknown constant here, some unknown constant there. I am going to just move it to the other side. I take this unknown pile of junk, mix it with this other unknown pile of junk, and I'm just going to call it a single C value of unknown rather than be like, oh, this is the unknown junk, the unknown coins that were in my left pocket. I'm going to add it to the money that was in my right pocket. Just say, I have this much spare change. Yes, Morgan.
So as long as you have a C somewhere.
Yes. And don't be cute or fancy. Add the plus C on the X side because normally with these questions you want to solve for Y. You want to get Y all alone. So start off with the extra junk with the X's. Okay, so I get slope field looking kind of like this. And these undefines. Yes, no? What does it look like?
A circle.
Circle
Or
Okay.
a cosine.
or a cosine? Like, it's a roundy thing. Okay. And again, this is supposed to be tomorrow, but let's try it now. So, Jacob, I want to separate the variables. I want y's with y's, x's with x's. What do I need to do to this?
Cross multiply.
Okay, cross multiply. Do I take the 2 and move it over here? Because the 2 isn't an x, it isn't a y. And you can leave it where it is or you can move it. What's your choice?
I choose to move it.
I choose to move it. Okay. Okay. When you see these problems on a free response question, it is often 5 points. You get 0 out of 5 if you don't do this first step, which is move the x's to the x's and the y's to the y's. And not any which way. dy needs to be up top. dx needs to be up top. Because Maya, you can't integrate if the dx is in the denominator. So Maya, can you integrate this 2y dy? Raise the power, divide by the new power. Well, raise the power to 2.
By 2. Divide by 2.
So is that it? The 2y and then the,
Simplifies, yeah.
so I don't have to write the 2 over the 2? So that's good?
Yeah.
Sydney, what about the other side? Negative x dx.
You read in a power of 2 and then divide by 2. So it would be -1/2 x.
So negative 1/2 x squared, can I write it this way? And Noah, I'm missing something.
Plus C.
Plus C, I gotta put a plus C on one side or the other. It is better to have it over here. Isaiah?
What's happening to dy dx when you're integrating?
Okay.
Aren't they turning into one?
So, remember those, you guys hated these, I don't know why, they're just areas of rectangles. We were approximating area under the curve by finding a bunch of rectangles, right? That was the height. This is the width. So the height times the width together multiplied to get area. So these two things combined while doing the integration, they merged. Right, okay. Isaiah's making a funny face. Look, I have height times width. And together, if it was a height of 5 and a width of 2, I get an answer of just 10. I don't have the dy and the y value anymore. These two things merged to become area, or the actual integration. So the dy disappeared in the process of integrating, and so did the dx.
Why
Yeah,
don't
like
we
that.
have, well, I'm wondering why we don't have plus 2 to y squared, maybe just because it looks different from.
Plus 2, y
Plus c, sorry. Plus C.
Okay, so I said that a minute ago. Random spare change in the right pocket, random spare change in the other pocket. I don't know how much was here. I'm just going to be like, you know what? I moved it all over here, and I'm just going to call it a single C. Not the little bit of change in the left pocket and the little bit of change that was in the right pocket. I'm going to just say, you know what? This is all the spare change I have. Didn't matter which pot it was in. He doesn't like that answer again. Okay.
I
You know-
probably get it.
Okay, it only needs to be added to one side. Don't confuse yourself by trying to do it twice. Morgan?
Why is the dy that width?
When we were doing that RRAM, LRAM stuff,
Yeah.
what is the width right here?
The x value?
The change in x.
Yeah. Oh, and d. Oh, yeah. Okay.
Okay, now, you guys probably don't know.
Wait, but it's changing a lot.
Conic sections, geometry, any recollection? No.
Conic section, sort of.
Conic sections, like, we did these. What is that shape? Circle with the radius r centered at 0, 0. So then there were things like this. Yep. An ellipse. Drop the C. An ellipse. This is an ellipse. It's kind of like an egg, right? And just because we're on a roll, what if it's a subtract? Hyperbola. Is this with the solar panel things open up and down or left and right? Okay, let's try this. When x is 0, x squared is going to be negative c. Where can a squared thing be negative? Never, so it's not going to cross the x-axis. Y squared, oh, that's going to be an up-down line. Yay! I'm distraught with how MCPS has rewritten the curriculum.
And also, the people in here had geometry during COVID. So,
Awesome! Even better! Rock
Wait,
on!
can you re-explain that?
Geometry.
like,
Eric,
for
it
the,
doesn't
March
matter.
through the end of the year.
Like, the importantness of knowing that stuff,
The
not
full
such a
code.
big deal because odds
It is
of
a
you
shape.
having to calculate the elliptical orbits of comets going by, probably kind of small.
No, the hyperbolic.
Yeah. Hyperbolics are used for cell phone tower things and radar.
Could you like
Which would be why that anechoic chamber was needed anyway. Sorry, what?
Could you explain what you were just explaining with the, how do you know when?
How do you know which way? Okay, well, when x is 0, y squared equals, I don't know, let's make c 4.
Mhm.
So y is plus or minus 2, right here, right there. Well, when y is 0, when is negative x squared equal to 4, or when is x squared equal to negative 4? It isn't. So when y is 0, the curve doesn't hit the axis. It gives us imaginary numbers, and welcome to BC Calculus or AB Calculus. For the love of God, we only deal with real numbers. It's hard enough. We throw things out if they give us imaginary stuff. Those of you headed to electrical engineering, learn to love the imaginary. Okay, good talk. Okay, so these look crazy, right? These are on your paper, I believe. So, is this on there or no?
Yes.
This specific one?
Yes, it's top one.
Yeah, it's the same.
It is, okay. The figure to the right shows the differential equation, 1 minus x times y. And they want you to try to sketch the particular solution that contains 0, 2. Okay, let's find the coordinate on the graph. Where is 0, 2? Isaiah, good morning. You're almost there. Yes. Okay, 0, 2. When x is 0, the y value is 2. There. So if you were a little leaf on the ocean being pushed around by currents that did this, try and draw where you think you would travel as that little leaf. I want to put it up for you. I want to see how you guys do this first. If you're the little leaf at 0, 2, find the coordinate 0, 2 on this. Put that dot, and now you're a little leaf. And what path did you come from? So go backwards too. So where are you getting pushed around? Gotta go backwards too.
No, backwards as well.
Backwards, sorry, thank you. Backwards as well, Jackson. Thank you.
I think one of the lines is a little too straight.
So it looks maybe like that. Like if you were a little leaf on the ocean, where did you come from? Where did you go to? What?
It's just following the slope curve.
Right. So if this distresses you, don't worry. They very, very rarely put this on there because it's hard to grade. Like,
Yeah, what are you gonna do? Like say, oh, it's
Well,
close enough to the line?
yeah, like what's close enough, what's not.
They said
They would, this is wrong. Like if your path is clearly cutting across the edges, like the slopes are going this way, you couldn't do that. Like that would be wrong. But it's hard, like, is that okay? You know, it's off by some. Is it off enough? Like, it's too much of a judgment call for them to honestly grade that. But just want you to see, it's sort of like this. It's going to be some kind of mountain. Good? Okay, and it said label this point A. Now, try drawing the other one now that we've done this at the coordinate -1, -2. Where would that slope field go? Into that? Cool. Good. And make it go from behind, through the point, and forward. Yeah, agree. So it kind of looks like a squirty eyeball now.
What is this equation?
1 minus x, right?
This is an equation that we can't do much more with. For where the curriculum goes for AB, we can't do anything else with this right now. So
We not-
it
type it
looks
into a
kind of like
graph?
that orange thing. Sorry, what?
Type it into a graph.
you can get an idea of what's going on in the function. Hang on. So you have homework on Delta Math tonight. Some of them are, hey, here's a graph of a differential. Which one would this match with? Any idea, like a quick way to eliminate some or pick some?
Just gonna be going straight down.
Guys, can you look up? What do you notice right here? All the slopes are, so when x is 0, the slope is 0. Okay, so could it be this one? Could it be C? No, because when x is 0, it's a number. When x is 0, the rest of these are going to be 0. All right, so
It's like the limit or the slope is infinite at -2.
So it looks like an undefined at -2 when x is -2. Unfortunately, that's going to be all of these.
Okay.
So, I mean, yes, good. Which one?
Is it at two positive two?
At positive two, this would also be undefined, but it's not. It's fine. So it's not that one. So good call.
Oh, true.
Okay.
I think
I don't like this at all.
you could look which one is positive or negative.
Let's see.
Wait.
I say something stupid all the time, and I'm recorded. All right, guys. There will be more hints for these on the Delta Mag.
Wait,